Today we are going to discuss about electric charges and fields. Actually, from examination point of view, this has a weightage of 4 marks, but it is very important chapter because to understand the next chapter, that is electrostatic potential and capacitors, this is very essential because first you should know what are electric charges, how do we define electric field, what is the force acting between the charges, all such things you must understand. Then only you can understand the definition of electric potential and working of a capacitor. Okay. Now let us start with this. You might have done a simple experiment with a plastic pen or with a plastic comb. So when it is rubbed against your body and you keep it on small bits of paper, the paper rises up and falls down, something like dancing up and down. Similarly, when you are ironing cloth, particularly polyester cloth, you might observe the hair on your hand will be rising, so they become erect, or you can feel some sensation, some pricking sensation you can feel. Same effect you can observe when you go near a TV screen when it is switched on or switched off. At that moment you will see some pricking sensation, or while combing your dry hair, then also you might have experienced the something slightly pulling off the hair or some cracking noise you might have heard. Similarly, if you do like this on a polyester shirt in darkness, you can see sparks. So all these observations, what we see is due to electricity. That is, the name electricity is drawn from a word of electron used for amber in Greek language. Some 600 years before Christ, a famous mathematician, I will show his photograph, Thales of Miletus. So this is the person about whom I am talking now. So he observed that when the amber rubbed with fur attracted small objects like fliff of cloth or small particles. So this attraction was first observed by him, and he gave the name electricity for the observed behavior of the amber. Amber is nothing but the liquid that dried after oozing from the plant. So something like your gum material. So the gum in the liquid form, and it comes from the plant or the tree. When it dries, it becomes something like a plastic material. So this property of attracting lighter objects by exerting a force is called electricity. The entities which are responsible for this type of attractive property are called as electric charges. Now we are going to discuss about the static behavior of such electrical charges. So when the electrical charges are not moving, then we call it as they are static. Now you can observe that there are two kinds of charges. So several scientists did experiments and finally concluded that there are only two kinds of charges. You can do the experiment and you can observe there are two kinds of charges. For example, take a glass rod. So that glass rod, when it is rubbed with silk cloth, it exhibits such attractive property towards small objects. Similarly, the ebonite rod or a plastic rod rubbed with fur or wool also shows such attractive property. So the glass rod rubbed with silk and the ebonite or plastic rod rubbed with fur, when brought together, they attract each other. But whereas when you bring two similarly rubbed glass rods or ebonite rods, they repel each other. So such experiments proved that there exist two kinds of charges. Now, it was the American scientist Benjamin Franklin. So Benjamin Franklin gave the name of positive charge and negative charge, because when the positively charged body and negatively charged body are put together, they get neutralized. They won't exhibit any such attractive property. So simply like numbers, adding numbers of equal value, positive and negative, what you get is 0, neutral. Therefore, keeping that in view, Benjamin Franklin named the charges as positive and negative. And by convention, the charges developed or produced on a glass rod when it is rubbed with silk is taken as positive, and the one developed on a plastic rod rubbed with fur is taken as negative. Now, once it is decided what type of charge is possessed by what type of body, then it is followed throughout the world, and the same convention we are still following. Then there is one apparatus about which already you might have studied, that is known as electroscope. Which is used to test the charge on a body. A dried potato called a stick ball suspended by means of a silk thread can be used for testing the charge on a body. Suppose a glass rod having some positive charge brought nearer the stick ball and touched it, then the charge gets transferred to this body, then becomes positive charge. Now this can be used for testing whether a body is charged or not. So an electroscope made up of gold leaves is also known as a gold leaf electroscope, which is a sensitive instrument. You can easily detect the charge on a body even at a distance from the knob of the metal rod. I am showing you one simple model which can be constructed by yourself, which you can make yourself and can test whether electric charge is present on a body or not. So let us see that video. I will play it for you and you can see it. See. Just a moment.
Really need gold leaves to make an electroscope? Not really. You can make do with simple stuff. Take a 20 centimeter of thick bare copper wire, bend a circle on one end. After placing a thick and thin plastic straw in the copper wire, fold the other end of the wire into a hook. Weave the hook through the central hole of a thick cardboard circle. Press fit the card circle in the plastic straw. Then cut 2 strips of paper 3 centimeters long and 1 centimeter wide. Punch a hole on one end of each strip. Hang the 2 strips by the hook. Now place the card circle on the glass with the hook hanging inside the glass. Now the electroscope is ready. To try it out, rub a piece of PVC pipe with wool. Soon the pipe will acquire an electrical charge. Bring the charged pipe close to the wire circle. Do not touch it. The charge from the pipe will travel through the copper wire to the hanging paper strips. As both strips will acquire the same charge, they will repel. You can see them visibly separated. On removing the pipe, the strips return to their original position. You can see this glorious action in a close-up. Instead of paper strips, repeat this experiment with aluminum foil strips.
So you have seen the electroscope. So that is used for testing the presence of charge on a body. Now There are, as I said, two kinds of electric charges present on present in any body. Actually, after knowing the structure of matter, scientists could explain the reason for the two kinds of charges. We now know that every atom consists of both positive charges and negative charges. The electrons are considered to have negative charges and protons positive charges. And since all matter is composed of atoms and molecules which contain these electrical charges, so these electrical charged particles in the atoms and molecules are responsible for the electricity observed in the bodies. Now, why you are observing only when the bodies are rubbed suitably? So the reason can be explained like this, and also we will classify the materials based on these electrical charges into conductors and insulators. Conductors and insulators. See, you will observe this attracting property of small particles by bodies when they are insulators. So as I said, plastic or glass, so wool or silk. So they are all not metals actually. So most of the non-metals which are not good conductors of electricity, we call them. Such materials, when rubbed suitably, they exhibit this electricity. So that electrification is because the energy is supplied to the electrons which are in the shells revolving around the nucleus. So they can be easily moved. So from the atoms over to the surface of the body. So the electrons that are moved over to the surface of a body, since they stay there because the body is not a conducting one, so the charges won't move away from that place. So that's why you can observe the electrification or the effect of these charges staying on the body. Now, when you do it with a metal object like a spoon or a metal rod, when you rub it, electrification cannot be observed because the charges developed on such bodies will flow through our body to the earth, or they may get neutralized due to the charges flowing from the earth to the body. So such metals, human body or animal body and the earth are said to be good conductors because the charges can flow through them, whereas wood, plastic, glass, porcelain, etc. They are called as insulators or bad conductors because they don't allow the charges to pass through them. That we call it as insulate. That we call it as resistance to the flow of charges. So they won't pass through such materials. We call them as insulators or bad conductors. So other than these insulators and conductors, in between there are other materials known as semiconductors, about which you are going to study in later chapters. Okay. Now, when we talk about these charges, we must discuss some basic properties of electrical charges. So, some basic properties of electrical charges. See, first one is additive property. Additive. That means, since a body is electrically neutral, the total amount of positive charges and negative charges must be equal to 0 because they must be present in equal number. So, the charges present on your body may be positive or negative. When you calculate the total, you must take that positive sign and negative sign also into consideration. Let us suppose Q is a symbol generally we use to represent a charge on the body. Actually here we consider point charges. Point charge means any object having charge such that the distance or the distance at which we consider the effect of this charge is much larger than the actual size of the linear size of the object. So if the object size is very much less when compared to the distances at which you are trying to find out its effect are greater, that is distances are far greater than the actual size of the charged body. Such bodies are called as point charges. So here the body, however big or small, depending upon the distance under consideration, we consider that body to be a point charge if it is very small in its size when compared to the distances. So let us suppose such a charge on a body which we call as a point charge. One is say some positive charge. There is some negative charge on the body, say some Q2 value. So plus Q1 minus Q2. Similarly, you have say some plus Q3 and then some another charge minus negative charge, like that. So you have to add them along with their signs, just like as in case of positive numbers and negative numbers, to find the total charge. Total charge. So this is the additive property of electrical charges. Then the second one is conservation. Conservation. So conservation of electrical charges. As you read in your first year about laws of conservation of linear momentum, energy, angular momentum, etc. Here also we can discuss about conservation of electrical charges. In an isolated system, you cannot create charges, you cannot destroy charges, because charges are already inside the body. Only thing what you are doing is by supplying some energy, you are separating the negative charges, whatever remains is the equivalent positive charge. So if you take some electrons from the atoms of your body, that much equivalent amount of positive charge that body will possess. So therefore, you only thing you can do is you can separate the charges on the body or inside the body. Even you can transfer charge from your body to another body, but in the whole system, total charge will be 0. So we say that, or let us suppose you cannot create charges, you cannot destroy charges. The total charge of a system is constant, is conserved. So in case of electrically neutral bodies, total charge is 0. Therefore, you may make a body positively charged by removing some electrons, or by adding some electrons, you can make it a negatively charged body. And since it is from one body to another body, you are able to transfer the charges, but you are not able to create them, or you cannot destroy them. But one thing is, in nature, a neutron-like particle, which is a neutral particle, can become a proton and an electron. That is, you are going to study in beta emission, in radioactivity, and in about elementary particles when you study, you will know that a neutral particle like neutron can get converted into a positively charged particle like a proton, and a negatively charged particle like we call that as a beta particle. It is nothing but an electron only. So naturally they will be created. But you see again, the charge conservation is there. Total charge is 0. So they may be at different places, but within that isolated system, within that closed system, you can say that total charge is conserved. So the conservation of electric charge is due to that charges are already present in the body. So you cannot get, or you cannot create the charges from somewhere else outside this system. So we consider that system isolated. So within that isolated system, if there are different bodies, you can transfer charges from one body to another body by different process, but it is not possible to create or to destroy electric charges. Okay, so that is about conservation of electric charges. And the third property is quantization. Quantization. That is, through several experiments, scientists found that electric charge on any body exists in some integral multiples of charge of a particular value. So the particular value later found to be the charge possessed by an electron. The quantization condition of electric charge was first observed in the laws given by Faraday in his electrolysis experiment. So in the laws of electrolysis, according to Faraday, it was observed that the electrical charges have some fixed values. That is what we call it as quantization. Later, it was Millicom. He did an experiment with oil drop, with an oil drop that is called Millicom's oil drop experiment, through which he could find out the charge of an electron, the smallest value, the value of electric charge any particle can possess. So he found that it is equivalent to the charge of an electron. So which is found to be 1.602 into 10 to the power of minus 19 coulombs. So that coulomb is the unit of electric charge. Actually, that unit is to be defined in terms of electric current. So again, what is electric current? If 1 ampere current flows through a conductor in 1 second, the quantity of charge that has flown is said to be 1 coulomb. So in terms of electric current, we define coulomb. Also, we can define coulomb with the help of Coulomb's inverse square. Let us discuss about it later. So the charge that is present on an electron, which is the minimum value that any particle can possess, was found by Millicom and is equal to this much. That is, we can transfer 1 electron, 2 electrons, 3 electrons like that from one body to another body, but not a quarter or half electron. Therefore, if you state this as the charge of an electron, the charge on any body must be integral multiple of that electron charge. Okay, so this is called as quantization condition. Now, we know that electron also has some mass. When you remove some electrons from a body, it will acquire equivalent positive charge, but slightly the mass decreases, because we know that electron is also having some mass, very little, but it has some mass. Therefore, we can say that the body which lost electron will lose a little mass. So the one which gains electron gets negatively charged, its mass slightly increases. So this is about quantization of charges. Okay. Then we will talk about methods of electrifying of charged bodies. That is, by electrical conduction or by induction, we can electrify a body. That is, electrical conduction and induction. Here, what is electrical conduction means? So if you want to charge a neutral body, you may carry the electrical charge from already charged body to this neutral body. So for that, actually a device called as proof clean is used. So it is just like nothing but a metal plate provided with a wooden handle. So as I told you that you cannot produce electrical charges on metal bodies by holding with your bare hand, because of conduction property, Even though the charges are produced, they get neutralized. So if you have a metal plate to which a handle, plastic handle or a wooden handle is provided, we call it as a proof plate. So by using a charged glass rod or a everett rod, you touch that proof plate. The charges will transfer to that plane, and that can be used to carry charges to another body. You touch it, another neutral body, as I said in the case of a pith ball, where that dried potato ball. So if it is neutral, by touching the charged body to that, the charge will get transferred onto that body. So this process we call it as electrical conduction. Then what is this induction? Suppose a neutral sphere, a metal body, is kept on a wooden support or insulated support, and you bring nearer to this a glass rod which is say some positive charge. When you bring near it, since it is having equal number of positive and negative charges, the negative charges get attracted towards this positive charge body, and the other side, the opposite charges will remain. And already you know that the opposite charges attract and similar charges repel. So that property also you might have studied. So when you bring a charged body near a neutral body supported on a non-conducting support, then what happens? Due to separation or due to attraction between the opposite charge particles, the negative charges will drift to one side, leaving the opposite, that is positive charges, to the other side. So you can take this body, and if you move it away, if the charges reside like this, we say a polarity is developed. But electrically it is neutral, but there is a separation between the charges. So that process by which you can induce the charges is called electrical induction. So this is what you observe in the paper bits, dancing paper bits. When the charged pen or the comb brought near over the small bits of papers, what happens? The opposite charges, that is, are induced on one side of the paper bit, and they rise up, and because the force of attraction dominates the gravitational force in that case, therefore they rise up, come into contact with the pen, and then it gets neutralized. Due to the weight, it falls down. So like that, what happens? Charging getting followed by induction getting attracted, and then they may acquire equal similar charges, they may get repelled, or so because this body has more charges, so this a part of the charge is used to neutralize the charge on the paper bit. So finally it falls down due to its weight after repulsion, and again by induction opposite charges are created and gets attracted, rises up. So this process of jumping takes place until the whole charge on the charged body gets neutralized or discharged. So actually this discharging is something like called as earthing. You might have heard that word earthing. In our household electrical connections, you will have 3 holes. You might have seen in the electrical boards. That is, one wire carries the current, that is, we call it as live wire. The other is neutral. This phase and neutral, or the live wire and the neutral, they carry the electric current from the power station. The third wire is connected to the earth through a thick metal sheet. So such earthing is used to protect the electrical appliances, because due to the electrical connections, the body of the electrical appliance may acquire electrical charges, or it may come into contact with the wire, live wire. So if it is earthed, then the charges may go to the earth, and therefore the persons working with that apparatus are protected from shock, electrical shock. So when the charge flows through our body, we call that as electric shock because of that reaction we feel due to some biological process. We feel what we call it as electric shock. But of course, if it is 60 volts or more than that limit, then only we feel that electric shock. So when at low potentials, we don't observe that shock. Okay. But anyhow, that electrical charges going into the earth through a conductor or through a connecting body is called as earthing. Okay, earthing is used to protect the persons working with the apparatus, and also that apparatus is also protected from electrical charges or electric current. Okay, so that is about earthing also. Then we will talk about the law, very important law, that is Coulomb's inverse square law. Okay,